All right, folks, so here is a recap on the last classwork, 7, 8, 9, and number 12. Okay, 7 is pretty straightforward. Here's a graph from Desmos. Okay, you can also graph this in your graphing calculator. Let's see if I can quickly do it right over here. So here we go. Second tangent x graph. Okay, and you can see, and if you truly want to find that coordinate, press trace 0, enter. Okay, and you get a 0, 0. Anyhow, here's the Desmos version, and you can see that okay, so you can see that there is actually, let's see if I can make that white right there. You can see that this means at x not equal to 0, it's inverse tangent of x. That means there's a hole right here for this. Okay. There's a hole at x equals to 0, 0. Okay. Or x equals to 0 of this inverse tangent graph, there's a hole. Now, it's saying at this, for this bottom one, at x equals to 0, y equals to 1. Okay. So, boom. All right. So, this is a discontinuity at x equals to 0, clearly. Okay. So, let's go to 8 now. All right. 8. Now, we have our original function here, and let's look at this pink to that pink. Okay. Now, if x is 5 or negative 5, let's say x is 5 here. 5 squared is 25. Square root of 25 is 5. Okay. Let's say x is negative 5. Negative 5 squared is 25. Square root of 25 is 5. So whether this is 5 or negative 5 for x right here, you're still going to get positive 5 here, hence the absolute value. The absolute value says that no matter what you put in for x here, you're going to get a positive number, hence the absolute value. Okay? So that explains this now. So whenever there's an absolute value, there's probably going to be 2 scenarios. Okay? So let's start with the positive scenario. Let's say it was x was positive 4. Okay. Let's just do 1. X was positive 1 and x was positive 1. Well, if x is positive 1, this becomes positive 1. Okay. Which basically becomes 2 times positive 1. Okay. Plus the 2. Okay. The same goes if this was 3, absolute value of 3 positive, absolute value of positive 3 is still positive 3. So then you would still get 2 times 3 plus 2. So if x is positive, in the last case it's positive 1, positive 3, or positive 5, positive 6, whatever, it's 2 times the positive number, whatever positive number you choose, plus 2. Okay? All right? Hence, all I'm trying to say, okay, all I'm trying to say is that this equation becomes this equation if you choose positive numbers for x. Okay? All right, now let's talk about negative numbers for x. Okay? Let's pretend this was negative 1. Okay? let's say x is negative 1, and then here x is negative 1. Well, the absolute value of negative 1 is positive 1, okay? So these are going to cancel each other out, and you're left with a clean 2, okay? All right. The same goes if you pick negative 4. If you pick negative 4 here and negative 4 here, negative 4 becomes positive 4, okay? So negative 4 and then negative 4 here becomes, the absolute value of negative 4 becomes positive 4. And this negative 4 and positive 4 cancel each other out, and you're left with just a clean 2. Okay, so long story short, if you pick negative numbers here for x's, the negative here and the resulting positive here from the absolute value will cancel each other out, and you will get a clean 2. So that's what this line right here is all about. Okay, so again, absolute values are going to create a piece, chances are absolute values are going to create a piecewise function with a negative scenario and a positive scenario. Okay, so now this honestly, because especially because this is a linear function, okay, I actually think that this is completely unnecessary. Okay, all right, you can honestly, you know the slope leading. Okay, so this is your xy axis. You know the slope of this horizontal line, because remember, this is y equals 2. The slope of this horizontal line is going to be 0. Okay? All right, the slope is going to be 0. All right? And the slope of this line is going to be 2, because in y equals to mx plus b, m is equals to 2. Okay? And because you have two slopes, okay, you have a slope. Here, let me actually just do Desmos to make it easier to see. Okay, and let me get this 9 out the way. All right, so your graph is going to look like this pink highlight here. All right, so the slope is 0 here, the slope is 2 here from that 2, and you can see visually that this is a cusp. Okay? Let's look at number 9 here. Okay, now, again, absolute values means there's probably going to be a piecewise function for positive, negative scenario. So I like to do the positive scenario first, okay, because that's usually the easier one. Now, if I like to pick real numbers. So let's say x is 1, okay, that's 3 times 1, and let's say x is 1 here also, okay, so you're basically going to get 3 times 1 minus 2 times 1, okay, and same goes here, okay, if you pick 2 here and 2 here, you're going to get 3 times 2 minus 2 times 2, okay? And so it's essentially, and if you pick any positive x value, you're going to get 3x minus 2x, which is just 1x, okay? So when x is positive, okay, and you pick any positive number, in the past case, 1 and 2, and in the later case, in the most recent case, you just pick a positive x, you're going to get 3x minus 2x, which is 1x. Okay? Now, let's pretend it is negative here. Okay? So I get negative Let's pretend it was negative 1 and negative 1. Well, you're going to get negative 3 here. Okay. And this becomes positive 1. Okay. Which is going to be, what's the best way of explaining this? I think the best way of explaining this could be just to use variables. Okay, so let's pretend we pick no, actually it might be, okay. Yeah, it might be just using regular numbers. So I'm going to pick negative 1 for x and negative 1 for x. So essentially this is going to be 3 times negative 1. And remember, this is positive. Okay, this is positive 1. So I'm going to get minus 2 times 1. Okay, minus 2 times 1. So this is actually the same. I'm going to rewrite this as 3 times negative 1 plus 2 times negative 1. Okay, I think we can all agree the answer to this is 5. Okay, I hope you see that I just switched around the negative and the invisible positive here, and the answer is still negative 5. So I just rewrote it. Okay, so this is essentially going to equal to, okay, 5 times negative 1. Okay, so if I pick negative 1 here, okay, let's recap on this. Negative 1 here and negative 1 here, and this negative 1 becomes positive 1. So I essentially get 3 times negative 1 here, and minus 2 times 1 is here. And I just rewrote the signs, negative, invisible, positive, into positive and negative. Okay, and I essentially get 5 times negative 1, which is negative 5. Okay, so I should say, so this is essentially the same as 5 times negative 1. Okay, you get negative 5 here and negative 5 here, same thing. Okay, so I think you can see that whatever x I choose over here, in this case negative 1, if I choose negative 2, negative 5, if I choose negative 1, negative whatever number, it's essentially going to equal to 5 times that number. Okay, so again, for x values that are less than 0, aka any negative number, is going to in the end equal to 5 times whatever that number is, hence 5x when x is negative numbers. So we got these two scenarios here. Now let's use Desmos. 5x minus 1 and x minus 1. Okay, and x minus 1. All right. And let's make way over here. And we can see that I copied and pasted the wrong section, or not big enough of a section. X minus 1 is blue. So we're going to go like this. We're going to get this pink and that. Okay, so your graph is going to look like this pink. We can see that this is a cusp. Okay, excuse me, a corner over here. Okay, cusp is when one or more of the segments are curved. Okay, let's look at this last one over here. Okay. Which of the following statements are true? Okay, so let C and E, so here's your answer. C and E are obviously false because f of x is continuous at 2. If I plug in 2 into here, 2 minus 2 is 0, absolute value is 0, absolute value of 0 is 0, and square root of 0 is 0. So this f is continuous, okay? So this is false. By the same logic, this is also false, okay? Now, by the way, just as a cheat, as a hack, I know you're not supposed to use a calculator, but just so that you can see what I'm talking about, okay? Your graph looks like that. This point's unnecessary. Okay? Now, D is going to be false also, okay? Because as we can see, as f of x, or as x approaches 2 from both sides, okay, as x approaches 2 from both sides, so let's look here. As x approaches 2 from both sides, y approaches 0. So this says y does not approach 0, okay, but it does, so D is false, okay? So now we're left with a choice between A and B, okay? When I see the word differentiable, I automatically think I got to take the derivative, okay? Or I think slope, and I have to find the tangent, aka take the derivative, okay? So here's the thing. Let's see how this became that, okay? Because the absolute value is a piecewise function with 2 scenarios. Now, by the way, this problem I will categorize this with the knowledge you have right now as a hard problem. Later on, it's not going to be that hard, okay? Now, so I previously said with absolute value, I like to start with a positive scenario, okay? So I'm going to pick, let's say I pick positive 5, okay? 5 minus 2 is 3, absolute value is 3, absolute value of 3 is 3, okay? So we can conclude that whatever x value I pick if I pick a positive x value, okay, it's just going to be x minus 2, okay? Or let me just put it this way. That was a terrible way of wording it. Whatever positive value I pick, if I pick a positive value for x, okay, okay, let me frame it this way. If I pick 5, the absolute value of 5 minus 2 is 3. So that's the same thing as doing 5 minus 2. Okay. Let's say I pick 6 here. Okay. 6 minus 2 is 4. Absolute value of 4 is 4, which is the same thing as doing a clean 6 minus 2 without an absolute value. Okay. Same thing with 7. If I pick 7 over here, 7 minus 2 is 5. Absolute value of 5 is 5, which is the same thing as doing 7 minus 2 without the absolute value. Okay? So when I pick positive values for x, okay, it's the same thing as doing that x minus 2 without the absolute value. Hence, okay, hence you just get x minus 2 without the absolute value for x values that are greater than 2. I mistakenly said positive x values. I meant x values that are greater than 2, which would make the value inside the absolute value positive, okay? So let me rephrase that because I said that kind of confusing. So as long as I pick values for x that are greater than 2, okay, it will be the same as if just doing that value I picked minus 2 without the absolute value, okay? You can see 7 minus 2 is 5. The absolute value is 5, which is the same thing as doing 7 minus 2 without the absolute value, which is what's going on here, okay? For x values that are greater than 2 is the same as doing x minus 2 without the absolute value. Now, let's say I pick values that are less than 2, okay? Let's try 1. Okay, if I do 1 minus 2, I get -1. The absolute value of -1 is +1. Okay, the absolute value the absolute value of -1 is +1. So this would be the same. This would be the same as if I did 2 minus 1. Okay, if I switch the 1 and the 2, okay, this would be the absolute value of 1, +1, which is 1. So, and we can, so again, when I pick values that are less than 2, it is the same as switching, instead, or let me just put it this way, instead of doing that value minus 2, it's the same thing as doing 2 minus that value. Okay, it's the same thing as doing 2 minus that value. Okay, so let's say I pick -3 over here. Okay, -3. All right. This is the same thing as the absolute value of -5, which is 5. Okay. All right. And that is the same thing as switching, okay, the -2, -3, and then this would be an absolute value of -5. Okay. And then this is 5. Okay. So all this is saying right here is that for x values less than 2, it's the same, doing the absolute value, okay, Wow, I had totally misspoke over here. Sorry, that's why I brain farted a little bit. So when you pick -3 over here, -3 minus 2 is -5. The absolute value of -5 is +5. That is the same thing as doing it without the absolute value. If you do 2 minus -3, okay, and you still get 5 here, okay? You still get 5 here. So all I'm trying to say is that for x values that are less than 2, okay, which is like that, you can just, instead of doing the absolute value, okay, instead of doing the absolute value, you can rewrite it as the switch of this without the absolute value. So the switch of this is 2 minus x, okay, or in this hypothetical case, 2 minus -3, and you still get +5, in this case, not using the absolute value compared to using the absolute value, okay? So that explains this. Sorry for the long-winded explanation, okay? I had to do it at least once, okay, this year. Now, we want to, differentiable, remember, means you want to find the slope. So when you, so we find the slope of this, okay? We find the slope of this, and here is all the work showing. That top one, okay, that's actually the bottom one. The top one is right over here, okay? This is the top one. And this says, by the way, 2 minus x covered up. Okay, so here's all the work. You can pause it and check it out. And you get to, no, I lied. Oh, I did not lie. That's correct. Just forgot the negative here. So I just want to show you how to get to this. Okay, so this became that through all this work over here. You can see I got -1/2, -1/2, okay? -1/2 here, -1/2. And then these two are basically equivalent, okay? These two are basically equivalent because negative exponents means you just move it to the opposite side, in this case, the bottom, and change the negative to a positive. Okay, this is basically to the power of +1/2. Okay, and by the same, so you can press pause if you want to check out this algebra right here. Here, okay, you can here, what was I going to say? Again, that's how I got from here to here is through this algebra. You can press pause to check it out. And you can see that this 1/2 is right here. And by the same logic of negative exponents I mentioned earlier, this moves to the bottom, changes to positive, okay? And you can see that you can plug in some, let's see. So you can plug in some hypothetical numbers over here. You can plug in 1. You can plug in, for example, 1 here, because that's less than 2. And you can plug in 3 here, okay? And you can see that once you plug these in, okay, it's not going to work out. They're not going to equal to each other, okay? And if you want to get even crazier, you can go 0.5 here, 1.5 here. You can plug in 2.5 here, and basically the slopes are not converging, okay? The slopes are not converging for this one, okay? Let's see if I can quickly show over here. Two minus 1. Okay. So this is going to be at x equals 2. So I'm going to evaluate this. Okay, 2 minus 1 is 1, root 1 is 1, so this becomes negative 1/2. Okay, negative 1/2. Now, this one right here, okay, I'm going to look right here. I'm going to plug in 3. 3 minus 2 is 1, root 1 is 1, so you get a clean 1/2. Okay, and you can keep picking numbers, and you can see that it is not converging, or better yet, yeah, you can see that it's not converging. Okay, okay, or better yet, you can plug in 0. Okay, you can plug in 0 over here, and you're going to get 2 over here, all right, to see what happens, to see if they are approaching the same. Okay, to see if there is a slope at x equals to 2. Okay, so you plug in 2 into here. 2 minus 2 is 0. Root 0 is 0, and 2 times 0 is 0, 1 over 0 is undefined. So the slope is undefined at x equals to 2, okay? I probably like that method than picking the 3, what I mentioned earlier, the 1 and the 3 and hypothetical numbers to see if they converge. That's actually kind of a pain in the butt, okay? So I would plug in 2, because the question is what happens at 2, okay? And the answer is that it is, you get a undefined slope, okay? Because 2 minus 2 is 0, root 0 is 0, 2 times 0 is 0, 1 over 0 is undefined. Okay? Sorry for the long-winded explanation, folks. Like I said, for absolute values, I got to do it at least once. Okay? Thank you for tuning in.